So now earlier videos we have gone through the given data as well as the tensile strength of the each channel, tensile strength due to yielding of the cross section and due to rupture as well. Now the next part would be to calculate total length of the fillet weld required. Okay, so that would be your step number 3. So total length of fillet weld required. So how much length will require to connect with the gusset plate as well as with the channel, and this is what we'll need to first of all calculate. So we'll be going through so in the page number 78, you have this clause 10.2.3 which says the size of fillet weld shall not be less than 3 mm. Okay, which is actually given in already table number 21 also. And if we talk about throat thickness which is also to be calculated. So throat thickness we need to calculate with the help of this formula. The effective throat thickness of fillet weld, it is again shall not be less than 3 mm and shall generally not exceed 0.7 into T, and where T it is the thickness of the thinner plate of the element being welded. Right, and this is how we need to calculate minimum size of the weld and throat thickness. So I'll simply write down here from clause number 10.5.3.1, that is page 78. We have this minimum size of the weld. So minimum size of weld, this is to be considered as thickness of the web minus 1.5, that is TW minus 1.5, and this is actually thickness of the web. We already got it in the step number 1, that is 6.5 mm. So 6.5 minus 1.5 mm, so you are getting here 5 mm. And let us consider using now 4 mm weld for the throat thickness calculation. So this throat thickness TT would be equals to 0.7 multiplied by 4. So this is going to be 2.8 mm. And now we need to calculate strength of the weld per mm. So therefore now strength of the weld per mm, and this is equals to page number 79, and we have this clause. Ten point 5.7.1.1, that is fillet weld calculation, design strength of the fillet weld, which is actually FWN by gamma mW. This is FWN, this is FU by root 3, and then FU is the smaller of the ultimate stress of the weld, and gamma mW, that is the partial safety factor. Right, so that is from the table number 5. So if you just look at first of all gamma mW here, so here we will get gamma mW, that is for the weld gamma mW, and it is 1.25. okay, that we would be using. So now this is equals to throat thickness multiplied by, so that is TT multiplied by FWN multiplied by divided by gamma mW, FWN divided by gamma mW. And now if you just calculate this, so TT, which we have already know, that is 2.8, then FWN, that is FU by root 3. FU, you know, you have this FU, that is 410 divided by root 3 and multiplied by 1 divided by gamma mW, that is 1.25. so here you will get it around 0.535, which is actually kilonewton per mm. What I am talking about, that is kilonewton per mm. So this is the strength of the weld, and to get the total length of the fillet weld, that is to be calculated. So therefore in the next step, that is the total length of fillet weld required okay, and that is equals to design strength divided by strength of the weld per mm. Strength of the weld. So design strength, you got it. Design strength, that is the 757.6 kilonewton divided by strength of the weld 0.535. Now if you calculate this, so you will get it around 1416 mm. So that's the total length of the fillet weld required to connect. So we will be going through the last step to calculate the total length of the weld required. This is what total fillet weld required, and how much weld distance or how much grooves we are going to consider. So that would be our last step, and then we'll go through the connection details. So now step number 4. Total length of the weld required. Total length of weld required. So here the overlap is limited to 400 mm, as you know. So maximum length that can be provided, so which we can calculate here. We can write down here overlap length is given already in the problem, that is 400 mm, and that is maximum which we can provide. So now maximum length that can be provided in the channel. So maximum length can be provided in the channel. Provided in channel. And this is equals to 2 multiplied by overlap plus depth of the ISMC. Okay, we have gone through the earlier So if we just consider this diagram, so here we will get, so this is 400 mm plus 400 mm, that you got here 800 mm, and you got here depth that is equals to 225 mm. So 800 mm plus 225 mm, that is 1025 mm maximum, but you require the total length of the weld, that is 1416. So what you need to do, you need to provide such grooves here, what I have shown here in the diagram. So how much length that should be, that groove should be, and will be going. So how much grooves? So this is, as I said, 1 2 3 4. There has to be 1 2 3 4. So we'll be calculating it. So this is actually, as I said, 2 into 400 plus 225. So this is 1025 mm, and we require the groove length. So therefore First of all, I can write down here, providing two slots of 25 mm, providing two slots of 25 mm, and let us consider x be the length of the slot. And therefore we can write down total length of the weld required and we'll calculate x here. So basically this is 2 into 400, this one, plus 225, right, and that is equals to 1416, which is the maximum that length we got in the step number 3. And as we have gone through the earlier diagram, so we require here 4x. So if we just solve this x, we will get it around 100 mm. So now the last will be going through the connection details. So step number 5, connection details. So as I said, you have to provide two grooves, and that is of 25 mm. So we'll be getting like this, right? And as I said, this 100 mm is actually this one is the 100 mm, and this is actually 400 mm. This is ISMC 225. This is also 400 mm. When we say this is 25 mm, this is groove of 25 mm, this is 100 mm. So 25 you got here 50, and remaining the distance would be here. So this, let us say this is 55 mm, this is 55 mm, and this has to be 65 mm. So here you will get like this connection details.